Then we are going to start, and I have the pleasure to introduce to Gerardo Jimenez. This is our first speaker. He is professor of the Harvard School of Public Health of the United States. He's president of the Global Biotech Consulting Group of Mexico, and is a member of a lot of advisory boards of organizations related to public health and genomics, such as OECD or Human Genome Organization. Thank you very much.
Thank you, and good afternoon again. My role this time would be not to talk about technology, but to talk about the economic impact that genomics is having in what it's called the bioeconomy, the economic growth. That is to say, genomics indeed is helping us to make appropriate diagnostics and decide on treatments, but what I will be touching on today is how genomics is contributing to creating wealth, well-being, but wealth in the world. So there are pretty much 4 trends suggesting potential contribution of genomics to the bioeconomy, and particularly in the case of personalized medicine. And I won't go into detail, but one of the elements that is creating a trend with potential contributions to the genomics, to personalized medicine and the bioeconomy is the drop in the cost of sequencing that we talked about this morning. So that's clearly an element that makes DNA sequencing available to pretty much everyone around the world. As a consequence, and I mentioned this morning how in 2006 the cost dropped dramatically due to the new generation, next generation sequencing, same phenomenon was observed, or I should say the equivalent occur with the number of species sequenced at that time. And this is how many species were there sequenced within in this decade, and we can clearly observe that 2006 and 7 the number increased, so much so that today, as of today, there are about 52,000 plus species whose genome has been sequenced. Again, this has created a tremendous amount of information that is that is contributing to creating wealth around the world. So having said that, and of course the genome that we are all interested on is the human genome, and here I refer again to yet another trend of research that is leading or translating the sequence of the human genome into functional, useful things, namely diagnostics, amongst other things. But as I said before, these are some trends indicating that genomics will be contributing to the economy. And one I want to point out that I have not mentioned throughout this morning was the economic evaluation of the Human Genome Project. The Human Genome Project, we all talk about the nature issue of the Human Genome Project and the results, but there is another analysis that analyzes how much money has the U.S. recovered from investing in the human genome. And here I'm only giving you an initial glance at it, where the Battelle report published in 2012, and then yet another complementary information a few months ago, shows that there was a return of investment of $141 per every dollar invested. There is pretty much no business, at least no legit business, that will give you $141 per every dollar that we've invested. So this is something that has called the attention of the world, and that along those lines, the OECD has turned their sight into genomics, and the OECD reported a few years back this report, the Bioeconomy 2030, where they define bioeconomy as the one based on the use of research and innovation in the biological sciences to create economic activity and public benefit. So it was very clear that the OECD was pointing out some guidelines as to how do we take genomics and create wealth. Wealth in the form of income for individuals, taxes for governments, new products, services, and so on. And so the OECD has indicated that there are strategies to meet global challenges, placing the biotechnology and convergence of technologies as drivers of economic growth, sustainable industries, and social well-being. And this is a point I want to make again because what they're saying is, yes, indeed, you can use genomics to diagnose the patient you're interested on. But you can also use genomics to tackle some of the global challenges that the world needs to address, namely healthcare, namely food for the world, namely energy sufficiency, and genomics can help meeting these challenges. And so in terms of economy, when we look at big challenges, we're looking at large markets. We're looking at larger revenue. So this is just the way the OECD is looking, is inviting us to look at genomics as a way to move the economic engine to create wealth in different areas. But again, focusing on the big markets, on diabetes, on nutrition, on energy, those markets where genomics can make an impact. And there are 6 areas that the OECD has indicated to identify, that they have identified trends, clear and secure trends where genomics is contributing to creating wealth. And those are human health, animal medicine, agriculture and food, industrial biotech, environment, forensics, justice, and security. And pretty much all of them have to do with public health. Maybe not directly personalized medicine, but the first one, and probably the second one as well. But the rest of them do have to do with human well-being and the creation of a good health care. So this is something to pay attention to. And this can only be done if we think out of the box. If we are there enough to thinking, how do we use genomics beyond just sequencing and reading? How can we add value to what we do with genomics? And for that, there are some elements that we might want to keep in mind in order to have what is called a virtuous circle of innovation, where we integrate genomics into the bioeconomy. The first element of this circle would be connecting ideas and connecting people. So connecting ideas and people across sectors to find new uses and applications for genomics. This means not only reading my genomes for my patients, for my favorite disease, but going out of the box, talking to other people, maybe in other disciplines, maybe in other fields, certainly in other countries, and see how can we use genomics to meet global challenges, big markets. Second element has to do with sustained investment. Sustained investment in large-scale science and technology to fuel innovation. This is important, particularly when we're talking about public funding, and when sometimes governments might say, we will invest in genomics, but then later, 2 years later, they have another priority. And then what happens is that this investment is turned into expense. There's no more investment anymore. It was just translated into current expense. And so if we stop investing in innovation, the circle breaks, and we can no longer compete at the global levels in terms of innovation in genomics. Now, the third component that is shown to be key for innovation in genomics is the idea of translating discoveries into applications to maximize impact across all sectors. This might sound pretty straightforward and logical to think of, but translating across sectors, this is what really makes the trick. This is what really allows us to access big markets, going across sectors as opposed to only diagnostics, only treatment, but going across and saying, how can we use this that I'm using, that I'm developing? How can I use it in agriculture and also in environment care and other different areas? So I'm just inviting you to think a little bit out of the box and see how genomics is creating so much wealth around the world. In the case of genetic personalized medicine, it indeed is growing. There's no question. The industry of genetic testing is growing, and here we see in purple the number of genetic tests, how it has been growing in the last 2 decades, whereas the number of laboratories in green is not really growing as fast as the number of tests. This slope is pretty dramatic, and even if this is up to 2012, if we were to see the actual number for today, there are about 39+ thousand tests that are already in the market. So the slope of this curve gets even more dramatic, and it's telling us that the industry is really pushing this forward. Now, the good news is that, as I mentioned this morning, there is some connection between the genetic tests and public policy. And I show you this morning the list of medications of drugs where FDA is forcing them to change a label to warn the customer. If we take a look at the speed at which these drugs with pharmacogenomic information on label have arisen, we see 1990, 2003, and 2013, and we again see a trend with a pretty deep slope here that will only indicate that regulatory issues will become a reality in a much wider format in the coming years. And then, as a third and last example as to how personalized medicine is coming to the market, I'll just show you this advertisement of a chain of clinics in the US that are currently translating what we discussed this morning in sequencing tumors and personalized therapy across the nation. So there is no question that genomics is becoming part of an important part of the medical industry. Now, not every discovery we make in the laboratory is innovation. Not every innovation will be a success in the market. There are several analyses and several factors that indicate when an innovation, and particularly in our field, will be a success or not. The first one I'd like to bring to your attention is from the payer's point of view. As I said this morning, someone has to pay for this. And so from payer's point of view, there are two primary elements. First element is per patient savings. How much does it cost to pay for this disease versus how much would it be to pay for the intervention indicated by the test? That's the first element. Second element is, what is the likelihood that my test will identify that individual that requires a change in treatment? So that brings the question as to how much per person will there be in terms of savings. And so for example, if we see some examples here, there are some companion diagnostics, for example, HER2, for breast cancers, where savings from change decision will be, in this example, $40,000. However, the probability to identify a patient with that needs with this test will be pretty high, and thus savings per test will be, in this case, $28,000. If we look into another companion test, such as BCR-ABL, again, in the first case, this is avoiding a very expensive treatment. In the second case, there is, again, a huge savings. However, This test won't identify many individuals as opposed to the previous test, and thus savings per test might not be as high. If we go to another kind of companion testing, such as pharmacogenomics in the case of warfarin, to avoid expensive side effects, then these savings are pretty low because we will only be adjusting the dose of the same drug, and the probability of identifying an individual who needs this is relatively high. However, since the savings is low from the new treatment, the total savings will be even lower. In these three cases, the three companion diagnostics go from $300 to $1,000, and in the three cases, there will be savings for the payer. Now, there are other examples, as in the case of BRCA1, and I will be describing these examples in the context of a general public open population, and in the case of individuals with a familial history of breast cancer. In both cases, if the tests were to be positive, the savings will be pretty much the same. However, in the general population, the frequency of these polymorphisms are so rare that the total savings will be pretty low. In the case of a familial case, it is a much higher likelihood that the test will identify an individual who requires the test a change in treatment, and thus the savings will be much higher. However, even though both tests cost between $2,000 and $3,000, in the first case, there won't be pretty much any saving for the payer, whereas in the second case, there will be savings for the payer. There are other extreme cases, and as in the case of these KIF6 mutations, where, as we know, some of them increase the risk for myocardial infarction. And this risk can be severely decreased if we use statins. So then we will need to pay, or the payer will need to cover the test, and if it comes positive, we'll have to pay for the drug as well. So there's two costs already, and thus savings are actually negative. It's payment what they have to do, and the frequency is pretty high, the likelihood of identifying one of these individuals. However, since it doesn't have any savings, total savings per test will be negative at all times. And in this case, it wouldn't matter how much the test costs, there won't be any savings. So in terms of payers, these are part of the cost-effective studies that need to be done in huge populations. And once again, what works for one population doesn't necessarily work for another population. So it has to be done in actual net cost for specific economies and for specific health systems. Another factor that contributes significantly is the turnover of customers when we're talking about commercial payers, that is private insurance. When there is high turnover, as in the case of those in the US, this becomes tricky. And here is an example in the pharmacoeconomics of BCRA1, where there is a cost for a test, and there is a cost for intervention in those patients where the test was positive. However, this is compensated by the savings of not having breast cancer in lifetime, and this is even more overcompensated but by the savings of not having ovary cancer through lifetime. So there might be a savings of, say, $36,000 in this case. This savings will be actual savings for the private payer if the patient remains with that insurance. If they don't, and they change insurance very often, what will happen is that cost accrues for the first payment, for the first payer, but when the actual disease might happen, those benefits will be taken advantage by the second payer. And this, again, this This we can observe is $36,000. This is actual savings as in the case of Europe, the United Kingdom, when these are lifetime care systems. In the case of the US, the number of years of coverage per plan decreases, the savings decrease and can even turn into cost throughout time. So once again, you can't just copy what works for one system and doesn't work for another system. These are examples as to how we need to filter out those innovations in personalized medicine before they make it to the market. And so I would like to point out the fact that these are issues that have called the attention of several governments. And thus, there are now national bioeconomy blueprints from the US, from the European Union, France, Germany, the Netherlands, Sweden, Finland, and other countries like South Africa, where when you review these blueprints, this cost effectiveness of the new innovations in genomics are central roles for these bioeconomy blueprints. And innovation in life sciences is the common denominator of these blueprints that bioeconomy blueprints that these countries have put out together. Now, in all of them, and except for the case of Europe, where there is a special case for healthcare, genomics and healthcare shows important potential to enable economic growth and development. So clearly, once again, healthcare and genomics is a major driver for economy. And I will give you a couple of examples here. I mentioned the Battelle report on the Human Genome Project, and if we look at what the US has produced out of the investment in the Human Genome Project, one for every dollar invested, in this case 12 years later, is $178 in economic activity. And that comes in terms of billions when you add up the years, and that comes billions in total personal income and billions in terms of increase in economic output since 2010. And the report indicates that only for 2012, the US created this amount of billions in the US economy, over 152,000 jobs and 18 billions in personal income. So clearly, the lesson that at least myself have learned from this experience, it's that investing, it's crucial. But really what matters is when do you invest? There is a window of opportunity, and there is a time for the leaders, and there is a time for the followers. Those who hit at early point and who become leaders, those get the highest revenues. Those who had serious and well-funded excuses and did not invest it timely will actually end up paying even higher prices for the benefits that other people will produce. That's the case of the US, and there's another example where two lessons I've learned. The Canada example, where Canada has invested $2.3 billion since the year 2000 when Genome Canada was created. And here, the lesson that I've learned is that half of it came from federal funding, and then the rest of them came from other sources, both provincial government, international collaborators, and private sector. So innovation at this time is really a matter of public-private interaction. Public-private interaction is something that we have to seek out of the laboratory to produce the products and services that we need in genomics. And as I said before, going across sectors is key, and this is something that the Canadians have made very explicit by the use of genomics. They have created wealth in all these areas beyond health, and the 2013-14 report published by Genome Canada 2 months ago indicated all these innovations opening up with other sectors make an impact. The last example I want to share with you is the one very close by from here, which is Genomics England, where the UK has now launched the 100,000 human genomes by 2017 through a public-private collaboration. And here there are 2 points I've learned I want to emphasize from this experience. Number one is the announcement made on August 1st by Prime Minister Cameron about a package of £300 million for genetic research, which will be devoted to transform how we understand diseases, particularly genetic diseases, rare diseases, and cancer. The point I want to make here is that political leadership counts and matters. So this isn't really a lot of money. If you compare with other, I mean, we talk about billions when we talk the US. We talk about the Human Genome Project, $14.8 billion. So 300 million pounds is fine. I'll get them. I'll grab them. I mean, I'll be very thankful if I were to get them. But really, it's not that amount of money. The point I want to make here is that political will, political leadership, can make a difference when they bring personalized medicine to the top of the political agenda. That's the one lesson from the UK. And the second one that I make is, again, private-public collaboration. This is the amount the government is putting in, and this is the amount Illumina is chipping in for such an attractive project. And finally, not at those levels, but in another modest strategy, Mexico has put together, Mexico, which is the 14th largest economy in the world, has put together a new organization called Genomic y bioeconomy, which pretty much is a non-for-profit organization to capitalize on government innovation. I already talked about what the government has been putting their money into in genomic medicine. Well, this organization is to translate that into goods and services for the Mexican healthcare. So this will promote, or is promoting, public-private associations to develop high economic value opportunities based on genomics, and it's actually, once again, going across sectors: fish, dairy, cattle, pharmacogenomics, all together. So I'd like to close by sharing some reflections as to how genomics innovation is propelling the bioeconomy. First of all, innovation in genomics contributes to the global economy: new products, new services, new companies. However, we need to define evaluation criteria for the successful integration of genomics-based interventions into public health. There are no clear criteria at this point, and there is no homogeneous criteria to decide what's good and what's useful at this point, particularly in public health. We need to identify case studies from which fundamental principles can be learned and used in different innovations so that we can propel them faster. We need to identify genomics interventions with high impact at a cost that makes them accessible to most of the population. As long as we do that, we can get to the largest markets and we can have the highest impact. And of course, we have to be aware of what the OECD is calling for: convergence of technologies that can contribute to reduce the gap between the path of sciences and what is needed to innovate in the context of global challenges. And my last point is the sounding need of forward-looking policies. We need to rethink the way we adapt research in academic models if we want to be effective in innovation. I don't think that the current models stimulate very much innovation and moving from the laboratory to a business company. Funding mechanisms in science should be rethought. Not only the impact of the journal you're publishing in, but the number of patents, the number of spin-offs, the number of products and services that your laboratory is generating should be taken into account. Evolution in concepts of sharing knowledge and sharing intellectual property. The world has changed. There's no longer one single individual owning the whole patentship the whole intellectual property. Today, there are different mechanisms to share IP and to get win-win situations for the different stakeholders. Knowledge evaluation, how much is knowledge? How can we monetize knowledge and bring it to the market? And finally, innovative governance and public engagement in the definition of priorities in which where should we invest as a country and where do we want to go. I will stop here, thanking again for the invitation and participating in this important session today. Thank you.